We are going to discuss about the introduction to the communication systems. Now we are going to have a brief introduction to communication systems. Now the purpose of any communication system is to transmit some messages between the source and the destination. The message is also called information signal or modulating signal and usually denoted as M of T. Now between the source and the destination, for the message to be transmitted, there should be some kind of transmission medium that is called a channel. There are two types of channels. One is the wired channel, the other is a wireless channel. Now a common wired channels are twisted copper pair, which is used in the landline telephones, and also fiber optic, which is used in fiber optic networks. Now the wireless channels are simply air and free space. Now we are going to discuss what are the various building blocks of a communication system. Information source, followed by the transmitter, then the channel and the receiver, and finally the destination. Next we are going to see the block diagram of a communication system. The information source, it generates the message signal M of T, which is given to the transmitter. This transmitter, it performs the operation called modulation, and this transmitter is using a high frequency carrier C of T, and the transmitter simply performs the modulation operation, which is a simple multiplication of the message M of T with the high frequency carrier C of T, and it will generate a high frequency version called modulated wave. This is represented as S of T. Now this modulated wave is given to the channel, passed through a huge amount of distance, maybe 100 kilometers or maybe up to 1000 kilometers, and during this process the noise N of T gets added. So on the receiver side, after the modulated signal has traveled a very large distance of, let us say, 500 kilometers, or in some cases even 10,000 kilometers, this signal at the receiver side is S of T plus N of T. This N of T is the noise that is added during the transmission through the channel. So this receiver, then it performs an operation called demodulation, and it recovers the message signal or reconstructed message MR of T, which is given to the destination. Now we are going to discuss about each of these blocks. The information source, it simply generates the information or the message signal M of T. The source can be a human being or a machine. Now in most of the telephone conversations, the message signal is usually the voice signal that is spoken by the human being speakers. Now this message signal M of T, it is actually converted into the electrical form using a transducer such as a microphone. So when we are representing the information source, we are actually assuming that the information source, which is the speaker, is also fitted with, along with that, there is a small block that is a transducer. So it is generating that electrical signal M of T. Now the next block is the transmitter. This transmitter, it performs the operation called modulation. This modulation, it converts the message signal M of T, which is usually a low frequency voice signal, and that is converted into a high frequency signal which will have higher energy, and this is called modulated wave. that can be transmitted over a large distance. Now the transmitter is sometimes even called a modulator. The modulator will simply multiply the message signal M of t with the high frequency carrier, and it generates a high frequency version of the message signal called modulated wave S of t. Now this is a very simple block diagram of a modulator. The modulator takes the low frequency message M of t as one input and high frequency carrier C of t as another input. Then it multiplies both M of t into C of t, and it will generate the modulated wave S of t, which is simply a high frequency version of the message signal M of t. Now next we are going to discuss the channel. The channel is simply a transmission medium which is connecting the source and the destination, and there are two types of communication channels as we already discussed: the wired channel such as a fiber optic cable or a twisted copper pair, and the other type of channel is the wireless channel. Air. Air is the transmission medium for the wireless channel for all terrestrial transmission within the surface of the earth. Whereas if we talk about free space, when you are sending a satellite from the earth to the moon, then the free space becomes a transmission medium for the wireless channel between the earth and also the outside planet like the moon or Mars. Okay, so the air usually refers to whatever is the wireless transmission which we are doing within the earth surface. Now, free space means when we are transmitting the signal from the earth to another planet, such as like a mission to the Mars, then it's the free space for the wireless channel. Now, this receiver is usually the opposite to the transmitter, so it performs the operation called demodulation. It is the inverse operation of modulation. So this receiver, it will take the modulated signal plus noise S of t plus N of t, and it will convert it into a reconstructed message called MR of t. Now, of course, this MR of t, which is a reconstructed message, it's only the approximation to the message M of t. It cannot be exactly as M of t. Now, finally, the destination is usually a human being or a machine. In a simple example of a telephone conversation or a mobile communication, the destination is a human listener who is listening to the human voice on the other side of the mobile phone call or a telephone call. Now, in some other cases, the destination can even be a computer that is performing some operations on the reconstructed message. Now we are going to discuss what are the various needs for the modulation. So as we discussed, modulation converts the low frequency message M of t into the high frequency signal which is having higher energy, which is called the modulated signal. And here modulation is the process of varying one or more parameters of a high frequency carrier, such as amplitude or carrier frequency or carrier phase proportional to the message. Now we are going to discuss what are the various needs for doing this modulation. The first need is modulation allows long distance transmission. Now, if we take any signal, the energy of the signal is proportional to the frequency. So, if we take this low frequency signal M of t and we convert it into a higher frequency signal S of t by mixing it with this high frequency carrier. Now, since the higher frequency modulated wave S of t that will have higher energy, it can travel over a longer distance. Now next, second need is modulation reduces the antenna height. The height of the antenna is proportional to half of the wavelength. So we can write the height of the antenna H ant as k into lambda by 2. Now we know the wavelength lambda is inversely proportional to frequency. So lambda is c by f, where c is the speed of light and f is the frequency. So substituting this, we are going to get the antenna height as k by 2 into c by f, or k into c by 2f. Now If we increase the frequency f by using this modulation process, as f increases, since f is in the denominator, the height of the antenna decreases. This is very useful for the practical communication systems. We want antenna with a smaller height. Now the third need is modulation allows ease of multiplexing. Now the process of transmitting multiple messages simultaneously over a communication channel is called multiplexing. Now by using modulation with different carrier frequencies for different messages, we can perform multiplexing. Hence this modulation, it allows multiplexing, which is very useful. Now finally, modulation reduces the effect of noise. The noise in the communication system N of T is usually a low frequency in nature. By doing the modulation, the message signal is shifted to the high frequency range. Therefore, by the modulation process, the message signal and the noise, they get separated in frequency. And therefore, the effect of noise on message will be reduced. Now we are going to briefly discuss about baseband communication. Baseband refers to the band of frequencies of the original message M of T, and in baseband communication, modulation is not performed. So this baseband communication, the modulation using the high frequency carrier is not done. So this message M of T will be encoded using a encoder, and the encoded signal is simply given to a transmitter filter G of F, which is like a raised cosine pulse shape filter. And we are going to obtain the encoded signal without any modulation, which is processed through this transmit filter, which is called the transmitted signal S of T. And at the receiver, whatever is the noise corrupted transmitted signal S of T plus N of T is passed through a receive filter QF, which is usually the inverse of G of F, and a decoder is also used, which performs the inverse operation of the encoder, and finally we obtain the reconstructed message MR of T. Now here we are showing the block diagram of a baseband communication. Again, in baseband communication, the modulation using high frequency carrier is not done. So we take the source, then we perform some encoding, then we use it to filter by using a transmit filter G of F, which is like a raised cosine pulse shaping filter. Then we are going to get this transmitted signal. This transmitted signal is still at the same low frequency range, that is the baseband frequency range of the original message. This S of T, which is at the baseband frequency range of M of T, is directly transmitted over the channel, and at the receiver side, the noise corrupted transmitted signal S of T plus N of T is passed through the receive filter, which is QF. This QF is usually inverse of the transmit filter GF. And then we apply the decoder, which will perform the opposite operation of the encoder. And finally, we obtain the reconstructed message. I want to thank all the audience for your patient hearing. Thank you very much.